Hello everyone and welcome back. So far in IUPAC nomenclature, we have seen the format, how to select the PCC and how to number the PCC. Today we are going to take the next step and put the different parts, prefix, the root and the suffix in place and get the final IUPAC name for the given compound. Before we move ahead, we need to make ourselves familiar with this priority order in which carboxylic acid gets the highest priority, then sulfonic acid, then anhydride, then esters, and so on. What it means is that if in a given compound you have two functional groups, let us say a carboxylic acid is given and alcohol is given, then we say that since carboxylic acid is placed higher in the priority list, carboxylic acid becomes our primary functional group and alcohol would become my secondary functional group or simply a substituent. Now primary functional group comes in the secondary suffix part. For example, if you are given a carboxylic acid, then its name will always end with the given suffix, which is oic acid or carboxylic acid. Carboxylic acid has two suffixes, oic acid, which we generally use, which is most commonly used, and carboxylic acid, this is a special suffix used in special cases. Likewise, even esters, the common suffix is OAT and carboxylate is the special suffix. There are various others which have a special suffix, all of which I have written in green font. Okay, so it's not that you can choose between oic acid and carboxylic acid. Okay, it's not that you can place any one. Oic acid is to be used in certain cases and some special cases carboxylic acid is to be used. Let us take some examples to understand it. Say that we are having a carboxylic acid containing 3 carbons. Then we always first select the PCC. It's quite simple in this case. This is my PCC, right? Once we have selected the PCC, the second step is to number. While numbering, make sure that you give minimum number to the functional group. So in my PCC, I have 3 carbons. All right. So it becomes, the root becomes prop. Since there are 3 carbons in PCC, all 3 carbons are connected with each other through single bond. So the primary suffix will become ane, propane. So this is my root, this is the primary suffix, and now comes the secondary suffix. What is that? Secondary suffix for COOH is oic acid. So the name would become propane oic acid. However, if we are given a ring, let us say cyclohexane, and then COOH is directly attached to it, in such cases when we have carboxylic acid directly attached to ring, we will use a special suffix that is carboxylic acid. So name of this guy is going to be cyclohexane. This is cyclohexane, and this group we say is carboxylic acid. Likewise, we could have cyclopropane carboxylic acid. So we use the special suffix when carboxylic acid is directly attached to the ring. However, if we have a ring and then there is a carbon and then we have our functional group, in such cases we will not use the special suffix, we will use the normal suffix. Why, sir? Because the carboxylic acid is not directly connected with the ring. Now in this case we need to decide who is going to be my PCC. Is my PCC the ring or is my PCC the side chain? Well, side chain becomes my PCC. That's because I have to always select the PCC in such a way that functional group is included in it. If I select this ring cyclopentane as the PCC, then I'm omitting out the functional group, which is not allowed. I have to always make sure that the primary functional group is included inside the PCC, and hence side chain becomes my PCC. Fine. So this one gets 1, this one gets 2. Why? Minimum number 2, the functional group. So at second position, I have cyclopentyl group. So this becomes second position, cyclopentyl. And rest is what? 2 carbon wala carboxylic acid, that is ethanoic acid. Ethanoic acid. So let's have one more example. We have cyclopentane, and here we have amide. Special suffix or normal suffix? Just check. Since the functional group is directly connected with the ring, we will use the special suffix. What's the special suffix for amides? Amide is a normal suffix. Carbamide is the special suffix. How to use it? Cyclopentane carbamide. Cyclopentane carbamide. So this is how we use the special suffixes. Now let us have one small example like this. In this case, my first job is to figure out who is the primary functional group. Sir, I have 2 functional groups, COOH as well as OH. Refer to the priority list. COOH is higher than OH. So COOH, carboxylic acid, becomes our primary functional group, and this becomes our primary functional group, and this guy becomes our secondary functional group or substituent. So we have to select the PCC in such a way that functional group is included inside it. Now once we have selected, we'll number it 1, 2, 3, 4. Now at third position, I have OH. What is the prefix for OH? Hydroxy. My point is quite simple, that primary functional group will come in suffix and the secondary functional group will come in prefix. So in this case, OH is simply a substituent for us and it will come in prefix. The prefix for OH is hydroxy. So it becomes 3 hydroxy. 1, 2, 3, 4 bute enoic acid. All right. Let us take few more examples before we proceed. This one, okay, and over here we will have, let us say, cyanide group. So I have 2 functional groups, carboxylic acid and cyanide. Who is my primary functional group? As per the list, this is my primary functional group, and therefore cyanide becomes a substituent. How to name this? Well, quite simple. We have a straight carbon chain. This is a straight carbon chain, PCC. I'll number it from this 1, 2, 3, 4, 5. Cyanide, CN. For CN, the suffix is nitrile or carbonitrile, that's special suffix, and the prefix would be cyno. So in this case, since it is a secondary functional group, we will use the prefix cyno. At 4th position, I have cyno, and rest is pentanoic acid. All right. I hope that is clear to all of you. Coming next to the ester functional group. Ester functional group, the prefix is very important. There are 2 sorts of prefixes we have. One is alkoxycarbonyl and other is alkanoyl oxy. If you carefully see, if the ester functional group is connected with PCC, through C double bond O. This is called carbonyl group. C double bond O is called carbonyl group. If carbonyl group is connected to PCC, the prefix becomes alkoxycarbonyl. And if to PCC, not C double bond O, but O is connected, then the prefix becomes alkanoyl oxy. Let me explain this with the help of example. Okay. Before that, let me tell you, this group is called carbonyl group. This group is called alcohol. However, if I get rid of this hydrogen, okay, then the radical which I have, RO linking to somebody, this is called alkoxy group. जैसे कि methanol, from methanol if I remove H, then the group I have would be called methoxy. This is meth, this is oxy, methoxy. Or ethyl group connected through oxygen would be called ethoxy. So let us say that I have a carboxylic acid group, okay, and through this 1, 2, 3, and here let me have this group. So I have two functional groups in given compound. One is carboxylic acid and another is ester. Who is my primary functional group? Obviously it's carboxylic acid. Now I'll start numbering the chain. 1, 2, 3, 4. You cannot consider this carbon in your PCC because this is a separate functional group or it is a separate substituent. Now see, to this PCC, C double bond O is connected. So at fourth position, whom do I have? Sir, I have two parts. Let us try to understand this. We have two parts. Sir, we have here CH3O, which is called methoxy, and we have the second part, which is carbonyl. So this entire ester substituent is made up of two things. One is methoxy, other is carbonyl. So we'll write it like this: 4 connected to methoxycarbonyl. The part through which it is connected to PCC will come later. It is not carbonyl methoxy, it is methoxycarbonyl, because carbonyl is connected to PCC. The part which is connected to PCC will be named later, methoxycarbonyl. Okay, 4 methoxycarbonyl. Rest is quite simple: butane, oic acid. However, if I had the same guy with a slight tweak in it, 1, 2, 4, like this, then what? Now see, again there are two parts. One is O and other is CH3CO. Let me tell you that CH3, this group is called alkanoyl group. Alkanoyl. Likewise, CH3CO, this, since there are two carbons, it is called ethanoyl. What it is called? It's called ethanoyl group. So this group I have ethanoyl and here I have oxy. So fourth position is occupied by this substituent, ethanoyl oxy. And rest is the same, butanoic acid. So these are certain things which we need to keep in our mind. Proceeding ahead. In case if you have any doubt, any difficulty, feel free to comment down. I'll address your difficulties. All these things we had done in our previous classes. You can see the PCC is selected and also numbered. Moving ahead. चलो इसका नाम लिखेंगे. Sir, we have these parts. We have root in our name. We have primary suffix. Then we have secondary suffix. And before that comes primary prefix and secondary prefix. Root comes from the PCC. Your PCC, it is having 4 carbons, so the root would become 4 carbon mane but. All carbons are connected with a single bond, so primary suffix would become ane, butane. And since your functional group is a carboxylic acid group, again there are two suffixes for that, but here we are going to use the normal suffix, which is oic acid. We'll use the special suffix only when COOH is directly connected with the ring. There is no ring over here. Name becomes butane oic acid. Okay, so are there any substituents? Yes, there is one substituent, methyl substituent at second position, so that comes in secondary prefix. Primary prefix is not there. Primary prefix is like cyclo, spiro and so on. There is no cyclic PCC over here, so not required. So our secondary prefix would be 2-methyl. So the name would become 2-methyl butane oic acid. Moving ahead, let's see here. So two functional groups are there, COOH and OH. COOH becomes your primary functional group, and this OH becomes simply a substituent or the secondary functional group. So the secondary functional group will go in prefix because it is simply a substituent. So OH is called hydroxy substituent. Its name is hydroxy when it goes in prefix. Of course, we know that this is methyl. H comes before M in alphabetical order, so that needs to be written first. So we'll say at 4th position I have hydroxy. At 3rd position I have methyl. And the rest of the name is quite simple, 5 carbons, so pent, all single bonds, so ane, oic acid. Why is hydroxy written before methyl? The secondary prefix, when you are writing secondary prefix, make sure you write all the substituents in their alphabetical order. So HIJKLM, so H comes before M and hence hydroxy is written before. Now here is an interesting question. Chalo. The functional group we know is carboxylic acid, 4 carbon wala carboxylic acid, so the root would become but, again but. Okay, 1 2 3 4. Okay, it's not ane because there is a double bond. There is a double bond at 3rd position, so butane, no, that's wrong, butene. But we need to specify where it is ene. It is at 3rd position, 3-ene. The double bond is between 3rd and 4th position, so it is starting at 3, therefore we write 3. But-3-ene oic acid. Now when you are going to write the substituent, now this is called a complex substituent. It's called complex substituent because it is not simple like methyl, ethyl, propyl. It has branching in itself. So this is a point of connection. This carbon is connected to the PCC, and from that there are 2 branches going. So whenever you have branching inside your substituent, such substituents are called complex substituents. For example, we'll take some examples, we'll understand it better. Let us say that we have okay. So here let us say that we have something like this. Okay, so now the PCC is this straight chain is my PCC, and I will number it from left side 1 2 3 4, because if I come the other way I'll have to assign it 5 number, 5 6 7 and 8. Now at 4th position I have this substituent. There is no simple name for it. Okay, so what we do is that we mark this carbon which is connected to PCC, so this carbon, and we assign it 1 number. Always the carbon connected to PCC gets 1 number, and from that one now you see or you traverse the longest carbon chain. Well, from 1 I can go to 2. Of course I could have gone the other way also, absolutely no problem, it's one and the same thing. What it means is that at fourth position, the longest carbon chain I get is of 2 carbons, that is I get ethyl. But that ethyl at the first position has methyl. So it is ethyl with methyl. The name would become, at fourth position, I have 1 methyl. See this? At first position there is a methyl and this is ethyl. So the name of the substituent would become 1 methyl ethyl and rest is octane. Likewise, similar structure we will take, and over here like this. Okay, again, so 1 2 3 4 5 1 2 3 4 1 2 3 4 5. So it's one and the same thing. 1 2 3 4 5 6. Now look, at fifth position you have a complex substituent. First, mark the carbon which is connected with the chain, and from here you traverse. You see the longest carbon chain that you get. So 1 2 3. If we had to go straight, 1 2, over here 1 2. So you selected the longest carbon chain from 1 2 3. That is propyl. It is a propyl group having 2 methyls at first position. So we write it as 1, 1 dimethyl propyl. 3 carbon propyl. 1 1 dimethyl propyl, and rest is 9 carbons, so non-ane. So that's how we name a complex substituent. Now coming back to this guy. Okay, so at third position I have a complex substituent. How to name it? Well, it's quite simple. Sir, the carbon connected to PCC, give it 1 number, the other gets 2. So this is ethyl. The substituent is ethyl, but there is one branch, there is one substituent inside it. So 1 hydroxy, this becomes 1 hydroxy ethyl. This becomes 1 hydroxy ethyl. Rest name is quite simple. It is, okay, we have already written but 3 enoic acid. Right? Moving to the next one. Well, that's quite simple. Sir, 5 carbon hai sir. So it becomes pent. At fourth position there is ene, pent 4 enoic acid. 1 2 3 4 5. So pent, at fourth position there is ene, so pent 4 enoic acid. What is there at third position? Okay, at the third position we have a bivalent radical. That is, it is connected not through a single bond but connected through 2 bonds, a double bond. We have discussed about such bivalent radicals in our very first class of IUPAC nomenclature. Okay, so if methyl group is connected through double bond to the PCC, we don't call it methyl, we call it methylidene. If ethyl group is connected through a double bond to PCC, we call it ethylidene. So this guy becomes, at the third position we have methylidene. So 3 methylidene, pent 4 enoic acid. I hope this is clear to you. Again, if you are finding anything difficult or any doubt is there, feel free to ask in the comment section. Chalo, moving ahead. We have already selected the PCC. We numbered it also. Sir, what is the primary functional group? COOH. They are there twice. Okay, so it wouldn't become oic acid. It will become dioic acid. How to name it? 1 2 3 4. So but. All are single bonds. Carbon, 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 carbon connected through single bonds. So ane. butane. Then 1 and 4th position there is oic acid, there are oic acid, so we write butane dioic acid, dioic acid. Now small technicality over here, sir. So far you are writing something like butenoic acid, you are writing in, you are not writing enoic acid, ये नहीं लिख रहे थे, you are not writing this e, or over here butane, here that e is not there. Why you are writing it now? Well, there is a rule which says that once you write this butane, okay, the next alphabet you check, the next alphabet is D. If this alphabet is not a vowel, or Y, of course Y is not a vowel, so it is not A, E, I, O, U or Y, then you must enter this E. Whereas if it is, then you have to omit that E. For example, if I had to write butaneoic acid, the next alphabet after butane writing is O, which is one of the vowel. So this E I shall not write. E is to be omitted if the next alphabet which comes is one of A, I, O, U or Y. So small technicality, remember that. What would be the name for the 6th one? We already selected the PCC, we have numbered it. It is 1, 2, 3, 4. Butane. Should I write E? Let us check. Butane, and here this is aldehyde. Suffix for aldehyde is al, Al. Butane, and 2 al's are there, so dial. This alphabet is not one of these, so I must enter E. This is butane dial. Okay, but there are suffixes, or sorry, prefixes. There is ethyl group over here, there is ethyl group over here, so we will write 2, 3 diethyl butane diol. Di means they are present 2 times, so di. Similarly, we may name this one. So the yellow way of numbering is correct. 1, 2, 3, 4. Why, sir? Because I have to assign minimum number to ethyl over methyl, alphabetical order. So the name would become 2-ethyl, 3-methyl, butane. Should I write E? Diol. Yes, because the next alphabet is not one of the vowels or Y. Let us try to name this guy. So which is the correct way of numbering? The yellow or the green one? Just check. So we have to assign minimum number to OH. 1 to 3rd position OH. 1 to 3rd position OH. So both ways functional group gets the same number. So we check in which way we can assign minimum number to the multiple bond. Sir, this way 1, 2. If I come this way, it becomes 3. So yellow way of numbering is correct, green way of numbering was wrong. So 1, 2, 3, 4, 5. So it becomes pent. 5 means pent. There is ene at 2nd position, pent to ene. And now the secondary suffix would be at 3rd position, there is or. Now you see, I did not write E because the next alphabet was O. So I did not write E because next alphabet was one of these guys. So pent, 2, ene, 3 all. Are there any substituents? Yes. There is a substituent at 4th position, methyl. So I will write 4 methyl, pent, 2, ene, 3 all. Moving ahead. Which is the correct way of numbering? Both are correct ways because it is a symmetric alkene. Okay, it is symmetric. You can number in both the sides. So hept, 7 carbons are there, so the name would become hept. Here also a small technicality that we must remember. Since there are two double bonds, it would become diene. So it would become 2,5 diene. But whenever you say diene, triene, or diene, triene, then you must write A over here. It is not hept-2,5-diene, it is hepta-2,5-diene, or hexadiene, or butadiene. But butene, heptene, if there is only one ene, then heptene. But if there are two or more, then you got to remember this, you must add hepta, A over there. So in fact, we call this suffix not diene, but adiene. Okay, moving ahead. Example number 9. Chalo. Very important example, very important example. I told you, here there is no functional group, so I have to select, of course it's a straight selection, I have to number in such a way that I assign minimum number to the multiple bond. At this point, I make no distinction between double or triple bond. For me, double bond, triple bond, both are same. So if I go this way, then I assign 1 to this multiple bond and 4 to the next one. So the set of locant is 1, 4. Backwards, 1, 4. At first position there is one multiple bond, at fourth position there is one more multiple bond. So 1, 4, that means there is a tie. That means there is a tie. And if there is a tie, then we will choose that way of numbering in which alkene or the double bond gets the minimum number. So I will end up choosing this method over this one. Why? Because I am assigning minimum number to the double bond. So let us name this. It is pent. Sir, is it penta? No, it is pent, because there is only one double bond and there is only one triple bond. There are no two double bonds. All right, pent. At first position I have ene, and at fourth position I have ine. Again, ene is to be written first, ine is to be written later, alphabetical order. And I did not include E over here since the next alphabet was Y. However, you see here, if I go from left side, the set of locants, second position multiple bond, fourth position multiple bond. But if I go other way, first position and third position. So first position is better than the second position, and therefore yellow way of numbering is correct way of numbering. Why? Multiple bond. I have to select first come first serve. But only when both the ways you end up having same set of locants, then you must choose that way of numbering in which alkene gets minimum number. Here first come first serve, here first come first serve. Okay. So yellow way of numbering is the correct one. It says it is pent, third position in, first position I. What should be the name for the 9th one? Just check. We already selected PCC, we already numbered it. It says hex. It is hex. 1 in 5 ine. Hex. Hex. 1 in 5 ine. And then there is a substituent at the third position. Who is that? So there is ethenyl. It is ethenyl. 3 ethenyl hex, 1 in 5 ine. Can you try this yourself? Try it yourself. Let us check. So the PCC is going to be this one. Why, sir? Because it contains maximum number of multiple bonds. Now, if I come from top, then my set of locant is 1, 2. Second position, there is a double bond. 3, 4, fifth position, there is a double bond. 6, seventh position, there is a double bond. But if I go backwards, if I go the other way, 1, 2, at second position, there is a double bond. 3, fourth position, there is a double bond. 5, 6, 7. So I will choose, see, 2, 2, same, 2, 2, same. 4 is less than 5. So that means this is correct, this is wrong. So I must number it from this side. It is non 2,5,7 triene. It is non, sorry, it is not non, it's non-A. 2,4,7 triene. Why A? Because there are more than one multiple bonds. At fourth position you have butyl group, 4 carbon wala, and here fifth position you have propyl group. So it becomes 4 butyl 5 propyl non-A 2,4,7 triene. Moving ahead. Yes, it's quite simple examples. Let us try to name them. So here selecting the PCC. Of course, this is my PCC. I have to number it from top like this, because if I go 1, 2, 3, here 1, 2, at second position there is a substituent. So this is heptane with second position methyl and fifth position also methyl. So the name would become 2,5 dimethyl. 2 methyls are there. Heptane. Similarly, you can try naming this guy or this one. They are quite simple, but let us try this guy. 1, 2, 3, we have already selected the PCC. It is octane. Now, at second position, there are methyls. At seventh position, there are methyls. So 2, 2, 7, 7, 4. So tetramethyls. At the third position, we have ethyl. At the sixth position, also we have ethyl. So we have 1 ethyl at third, 1 ethyl at 6. So 3, 6 diethyl. Chalo, theek hai. At second position 2. At second position 2, and at seventh position 2 more. 2, 2, 7, 7, 4 times. So tetramethyl. Octane. 8 carbons, so octane. The next example is very good example here. We have 2 functional groups, carboxylic acid and aldehyde. Carboxylic acid higher in priority, primary functional group. This guy becomes my substituent. Again, let me tell you, if CHO group is left outside PCC, then इसका नाम हो जाता है formyl. Prefix becomes formyl when CHO is completely out. Whereas if CHO is inside PCC, then this group is called oxo. If entire CHO is outside, formyl. If C of CHO is inside PCC, then oxo. So C of CHO is inside the PCC, therefore oxo. All right. So check over here, 1, 2, 3, 4, 5. So this becomes pent. Pent, all are single bonded carbons. So pentane-oic acid. This becomes pentane-oic acid. Now look for the substituent. Ethyl, methyl, and this is oxo. So E comes first in alphabetical order. 3 ethyl, 4 methyl, 5 oxo. 3 ethyl, 4. So E comes first, M, then O. So just check. We'll go ahead. Chalo. 17th example is also a very nice example, because I told you if cyanide is not your primary functional group, it is always going to be left outside. The suffix for cyanide is nitrile and prefix for this guy is cyano. Since COOH, carboxylic acid, is your primary functional group, this guy becomes your secondary functional group or substituent. So we'll say that 3 cyano butanoic acid. 6 carbons. So hexanoic acid. Hexanoic acid. Now entire CHO outside PCC, so its name becomes formyl. This is ethyl. EFG, E comes first, so 3 ethyl, 4 formyl, hexanoic acid. Who is the functional group in the next one? It is alcohol. So 1, 2, 3, 4, 5, 6. This is hex, all connected through single bond. Ane, hexane, all. Because OH is a primary functional group, the suffix for alcohol functional group is all. So it is all, but at which position? Second position. So it becomes hexane to all with methyl group at fourth and also ethyl group at fourth. So alphabetically, I will write ethyl first. So it becomes 4 ethyl, 4 methyl, hexane to all. I hope you guys are following. If any doubt, please comment down. 1, 2, 3, 4, 5. Sir, which is a functional group? CONH2 is an amide functional group. This is an amide functional group. This is an amide functional group. I told you there are 2 suffixes for amide. One is simply amide and other is carbamide. In this case, cyclohexane, carbamide. When the functional group directly connected with the ring, we will use the special suffix which is carbamide. But in this case, it is a normal suffix amide. So it is 5 carbon wala amide. It becomes pent. Ane, no, there is a double bond. So pent 3 ene. Pent 3 ene amide. Sir, here you specified 2 all. Here why are you not specifying 1 amide? Amide, aldehyde, carboxylic acids, these are called terminal functional groups. Okay? And therefore, wherever they stand, the PCC starts from there. Therefore, they always get 1 number. So it's trivial to write 1 number. It's trivial to say that this is 3 in 1 amide. It is understood that it is 1 amide because you cannot have 2 amide over here. It's possibly nahi hai. You try it. So it becomes pent 3 in amide, and at the second position we have propyl group. So 2 propyl, pent 3 in amide. Okay. So these examples we have already done. जैसे कि basically here the main challenge is only to number the PCC. So from left or right you get the same set of locants, and therefore you assign or you take up that numbering in which you are assigning minimum number to the multiple or the double bond. Rest are quite simple. Let us try one like this one. Okay. So bromo and methyl. Bromo must get minimum number 2. Fine. So at second position there is bromo. At third position there is methyl. 2 bromo, 3 methyl butane. What do you think we should be the name of this one? Again, the challenge was only numbering. Sir, this side also 2,3. Sir, this side also 2,3. Both ways the set of locants is 2,3. So we chose that way in which bromo gets minimum number in comparison to Cl, chloro. Sir, why? Alphabetical order. So it becomes 2 bromo, 3 methyl butane. ये देख लो. Sir, both ways the set of locants would be what? Here it is 2 3, 4, 5. So 2, 5. This way it would be 3, 6. So 2, 5 is better than 3, 6. In case you are finding the numbering difficult, please go back and check my previous IUPAC videos. So here we have 2-methyl, second position, that is methyl. We have solved the exact same examples. I'm continuing from that. Sorry. 5-ethyl, 2-methyl heptane. Again, make sure that you have listed the substituents in alphabetical order. E comes before F. These ones you can do yourself. Sorry, and this is one example which I had done in my previous class, just to give you a preview. And that's it in today's class. In our next class, we will see how to name the cyclic compounds. So far, let us quickly recap. We have studied what is the format of IUPAC, how to select a PCC, what are the rules for selecting PCC, and what are the rules for numbering the PCC. And in today's class, after the numbering was done, how to write a name from that. We have done it today. And in our next class, we will see how to name a cyclic compound. And also we will have a look at some special compounds which are very important for our JEE, NEET as well as our board exam. Thank you so much.